But an uneven distribution is cytoplasm. Obviously, the chromosomes are going to be inside the cell, but I'm just not putting them in there.
So they split up and one went north, one went south?
Yeah.
So
Okay.
they can go, they can
Either
stay
way.
together or they can,
Well, when we split them are at the allele, just like we did in the male. So this could go with that, or that could go with that, depending on how they line up. So
But
it's
they
not
won't-
like this is going to go with that one. They're going to have to. This would have to flip,
okay.
actually, during, you know, and like whatever way they line up, they're going to separate.
Oh.
But the lining up is random. So what chromosomal pattern is this? We have N and 2 copies of each N. So these are now haploid cells. This is identified as our secondary oocyte. And this is identified as the first polar body. It's not named a secondary oocyte. So at ovulation, I've drawn them separate, all right? But as the egg is developing, as the oocyte is developing, a protein coat develops around it. We'll talk about that when we go through the follicular development, known as the zona pellucida. So in actuality, what we're seeing here appears as this. And that's the zona pellucida. So the first polar body and the secondary oocyte remain very close to each other, and that's what you're seeing here. So this blue layer is the zona pellucida. All right, and then here would be the secondary oocyte, and this would be the first polar body. But they would have the same chromosomal patterns. The large and the small cell would still both be 2 parentheses in. Okay. That secondary oocyte, first polar body, and that's what's ovulated. So we look at the diagram up here. These are all primary oocytes. This is a secondary oocyte and the first polar body. Now, if it never meets up with the sperm, and even if it does meet up with the sperm, but the sperm don't make their way through the zona pellucida, this is the way the cell stays. It never undergoes, the second meiotic division. It stays as a secondary oocyte until fertilization occurs. So tomorrow, we're going to pick this up again with fertilization and follow that through. All right? But I want to, let's assume fertilization is occurring, and we'll follow it through to the oocyte stage. Now, so can I erase this? May I erase this side of the board here? Okay.
Yes.
I didn't know if that hand raise was wait a second. All right. Hold on. So if it does get fertilized, all right, and the sperm penetrates through the zona pellucida due to the acrosomal reaction of all the other sperm, and binds to the plasma membrane of the oocyte, again what we'll talk about tomorrow. Then it will undergo the second meiotic division, make a second polar body, and make a secondary and make an ootid. So what's our chromosomal pattern now? N. The ootid does not exist for very long, because remember why we triggered how that second meiotic division was triggered? The fusion of the head of the sperm. So along with our ootid, we're going to have the sperm nuclei over here in the corner. And those will travel towards each other and will have a zygote as they start their first mitotic division. Okay. So our ootid actually already has the sperm pronucleus inside it. It's not yet a zygote until those associate and the chromosomes pair up with each other, and we have a new 2N cell. Okay, so that hasn't quite happened yet.
Sperm pronucleus?
So that's starting to happen in these models. So this model, well, actually this is a better one over here. So this model doesn't show the first polar body, but shows the sperm binding to it. And in this model, here's the sperm material, here's the egg nucleus, and the second polar body, but not the first. Okay, and we have another one here that shows both of them. So here we have the sperm and the egg nucleus that are making their association, and we have the two polar bodies, the first and the second polar bodies up here. So once the sperm chromosomes and the egg chromosomes line up as alleles in one nuclear structure, then we have a new 2N cell. So in this case, this is in and this is in. It's not yet a 2N. We just have one cell's components inside another cell. Okay, and we'll look at that when we talk about fertilization tomorrow.
But technically there is two changes.
Yes, but they don't belong to the same cell. That makes sense. So we don't really talk about an ootid any more than just this part. Because within a few moments, it will be a zygote, which is the fertilized egg. And that will be a 2N, just like any other body cell. So our names are the same. We have the oogonium, we have the primary oocyte, we have the secondary oocyte, and the ootid. But their appearances are very different, and the size of the distribution of the cytoplasmic material during meiotic division is different. So now let's look at the egg with its chromosomal changes, and not chromosomal changes, but hormonal changes. are the changes that the cells are going through that surround the egg, what we call the follicular cells. So the follicle are those cells that encapsulate the oocyte. And those undergo changes along with the oocyte and contribute to the levels of the hormones. So let's look at those follicular changes. And you have those in your lecture notes described. You can see them on the ovary that I had up on the image previously, or you can see them individually on page 118. And we'll come back and look at the hormonal changes that cause that to occur. The terminology that I use is a bit different than the terminology in anatomy and physiology book that comes from my training with the histology through the medical school. And so when the baby girl is born, all through childhood before puberty, the oocytes are surrounded by a single layer of flat epithelial cells. So your textbook identifies this structure, this association between a single layer of flat follicular cells and the primary oocyte as a primary follicle. As a primordial follicle. My term is a primary. I don't ever use the word primordial. Okay? So if we have a primary oocyte and flat epithelial cells that are not making estrogen, that is a primary follicle. And this is what would be what the baby girl is born with until puberty. Yes?
What did you call the flat cells?
The what?
The flat cells? What did you call
They're just follicular cells. As we move into the growing follicle, they can be identified as granulosa cells. I'll accept either or.
They're not
Okay.
that big there.
Not yet. So this is a primary follicle with a primary oocyte. All of our follicles are going to have primary oocytes, right? It's the very last mature follicle, just minutes before ovulation, that is actually a secondary oocyte. Now, under influence of FSH, the single layer of flat cells will form a single layer of cuboidal cells. Still a primary oocyte. But now these have gotten larger, kind of like osteoprogenitors or cells get larger as they form osteoblasts. What organelle would be the primary component of these cells? The reason why they go from flat to rounded cells. What would be the primary organelle component of these cells, causing them to change, increasing in number, causing them to change from squamous to cuboidal? What is the change in activity of this cell? What is it making? Is it protein? What's the molecule that increases in number and amount as this cell develops?
Ribosome.
It rhymes with.
You're here's all the pictures put together. Here's our changing follicle. What hormone is getting estrogen? Okay, what kind of hormone is estrogen? Steroid. What kind of organelle do we need to synthesize steroid hormones from cholesterol?